So this might have otherwise have been a challenge problem before, but now we're recognizing this is really just a 4 or a 5 on the AP test that you're scoring. So lots of you should be able to do this problem with some practice. You've been asked for maxes and mins, which will happen where the derivative equals 0 or is undefined, so we need to take a derivative. I started with writing things out as negative powers, took the derivative using the power rule, and then put them back into the form that the problem was originally given, because figuring out where the derivative is 0 or undefined is probably easier found if there's a common denominator. So if I make a common denominator by multiplying the first term by x over x, I really get negative 2x plus 8 all over x cubed. That's my derivative, and I want this to equal 0 or undefined. Any fraction is 0 when the numerator is 0, and any fraction is undefined when the denominator is 0, because we can't divide by 0. So we'll set each term equal to 0. Negative 2x plus 8 equals 0 finds a 0. X cubed equals 0 finds undefined. So this will occur when x equals 4. This will occur when x equals 0. So we have two possibilities for maximums. Now I have to determine whether I change from positive to negative to positive, or neither. So what I'm going to do is test values left of this 0, between the zeros, and right of the zeros, or really undefined locations. And so as I do this, I'm just looking for what is the derivative, positive or negative. When you plug in each value of x into your derivative, we get negative 6, which is a negative number, positive 6, which is a positive number, and negative 2 over 125, which is small but negative. So if I plot them on my derivative number line, we're looking at negative, positive, negative, or negative, positive, negative. That would mean that I have a min at 0, and it would mean I have a max at 4. The only problem with actually having a min at 0 is my original function was undefined. So it's not a minimum, it's something that looks like a minimum. It's an asymptote. And then we rise up to have a maximum at x equals 4. So the only true max was at 4. I gave credit for minimum at 0, but it's not really, because it's undefined. It's an asymptote. Now we'll tackle the points of inflection in the same way. We want the second derivative to equal 0 or undefined. I'll go back to this derivative that's already in negative power form and take its derivative, and I'll put it in fraction mode, and I'll find a common denominator just like I did before. So 4x minus 24 all over x to the 4th. That's really equal to 0 or undefined. Same thing, when my denominator is 0, I'll be undefined. When my numerator is 0, I'll be 0. Suggesting I could have points of inflection at x equals 6, because that solves this, and again x equals 0. Testing my values of negative 1, 1, and 7 into the second derivative this time, we get a negative number, negative 28 over 1, another negative number, negative 20 over 1, and now 4 over 7 to the 4th, which is small but positive. So this is where I have my sign change from negative to positive. This is therefore where I have my point of inflection at x equals 6. So final answer, x equals 6, and only 6 is a point of inflection, because there was no sign change at 0. I was negative and negative. And so what that would mean is my graph would look something like this. I'd have a maximum, and then I would change from concave down to concave up, right at x equals 6. This would continue on this way, and that's something like what your graph would look like.